Alright, so in the next section, we are going to take a look at shortcuts to find derivatives. Alright, so first, if we have a constant function, okay, in other words, y equals 3 or something like that, a horizontal line, well, a derivative we've talked about just means slope. So the slope anywhere on a horizontal line is 0. So what we would say is the derivative of any constant function is 0. So down here, right, we've got y equals -4. So we can say that y prime would just be 0, right? Remember, this is our notation for a derivative. If my function is s of t equals 45, well, I can say s prime of t is 0. Same thing here, just our notation to show the derivative, right? Even if the function is the horizontal line of 0, its derivative would be 0. And here, all of these are just constants, right? K, so usually A, B, C, K, those are letters that stand for constants. So pi is a constant, K is a constant, 2 is a constant, all of those are constants, we would still say that the derivative is 0. All right? Now, if we have a single variable, in other words, like y equals x, if that's my function, well, if we're thinking about the slope of this line, well, the slope everywhere on this line is 1. So, if I have a single variable, the derivative is just 1. So I would say f prime of x here equals 1. S prime of t, even though it's a different variable, it's still the same idea. Right? And x prime of t equals 1. Right? Again, we're just talking about the slope. So let's kind of go a little bit more general now and talk about the power rule. This is a very, very useful shortcut to find the derivative of any polynomial function. Okay, so if we have x raised to some power, then the derivative of that, and remember this is our notation for the derivative of a function, okay, d over dx of the function. All we're going to do is bring the exponent out front and then subtract 1 from the exponent. Okay, so for example here, if I have y equals x squared, the derivative of that would just be 2, bring the exponent down, and then subtract 1 from the exponent. So 2 minus 1 would be 1, so 2x to the first, which we could just write as 2x. All right, and remember we used our definition of a limit to calculate all of these before. We used this f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Oops. So if I were to go through this process for x squared, my answer would end up being 2x. Okay, but this is a very useful shortcut. Okay, all we have to do is bring the exponent down and subtract 1 from the exponent. So here in b, my derivative would just be 4x to the third. Bring the exponent down, subtract 1 from the exponent. Now in C and D down here, these are not written such that we see an exponent. Okay, I mentioned before already that we want to get in the habit of writing roots as exponents, and even if we have a variable in the denominator, bringing it up so that we have a negative exponent. So before I take the derivative, I'm going to rewrite my original function here as x to the 1/2. Right? A square root is the same as the 1/2 power. So I can use the power rule here. I can bring my exponent out front and then subtract 1 from the exponent. So 1/2 minus 1 would be negative 1/2. So the derivative of the square root of x would be 1/2 x to the negative 1/2. Okay, now for our purposes, we can leave our answer like this, but if I did want to clean this up a little bit, this would actually be the same as 1 over 2 times x to the 1/2, which I could then, if I want to rewrite it as a root, would just be 1 over 2 times the square root of x, like that. Okay, but for our purposes, we can leave our answer like this. All right, so I mentioned here, we want to rewrite this with a negative exponent. 1 over x would just be the same as x to the negative first, and then it's very easy to apply the power rule. So g prime of x, bring that exponent down, so negative 1 times x, and then subtract 1. So negative 1 minus 1 would be negative 2. And again, we can leave our answer like this, but if I did want to make it look a little bit nicer, this would be the same as negative 1 over x squared. Okay? So, we can... Oh, sorry, I forgot about these. So, same idea here. I can, before I take the derivative, rewrite this as x to the negative second power. Then the derivative would be negative 2 times x to the negative third power. Okay? Here, same thing. Before I take the derivative, I can rewrite this as x to the negative 2/3. And then I can bring that exponent out front and subtract 1 from the exponent. So negative 2/3 minus 1 would be negative 5/3. Okay, and these would be my derivatives. And again, just to reiterate, a derivative tells me the slope at any point of my original function. All right, so if I were to plug in 2 into my derivative here, whatever value I get out would tell me what the slope of my original function is at 2. Okay, so we can actually, that's kind of messed up a little bit there. So this is saying if we have a times x to the n, if we just have a coefficient out front already, then the derivative, I just bring the exponent down and multiply it by my original coefficient. Okay, so a times x to the n, the derivative would be a times n times x to the n minus 1 power. Okay, so a couple examples of that, and this is the same idea as what we just did, right? I would just bring the 2 down, so y prime would be 2 times 3x and subtract 1 from the exponent, right? So this would just be 6x. Here, s prime of t, right? I just bring the 3 down, so negative 5 times 3 would be negative 15 t and subtract 1 from the exponent, so negative 15t squared. So again, make sure that we are rewriting with either fractional exponents or negative exponents, right? We want everything to have an exponent and we want it to be in the numerator in order to use the power rule. So here, before I take the derivative, I'm going to rewrite this as 6 times x to the 1/2 power. Then I can take the derivative and say this would just be 3x to the negative 1/2. Right? I just brought the 1/2 out front, multiplied it times the 6, and subtracted 1 from the exponent. Here, I'm going to rewrite this before I take the derivative as 3 times x to the negative second. Then the derivative would be negative 6x to the negative third. Right? Just bring the exponent down, multiply by the coefficient, and subtract 1 from the exponent. All right. So here, this one, again, rewriting this before I take the derivative, I would have 4 times x to the negative 1/2 power. Right? A root in the denominator I can rewrite as a negative exponent. So the derivative then would be negative 2x to the negative 3/2 power. Right? Multiply 4 times negative 1/2, and then subtract 1 from the exponent. Here, again, rewriting this. So the cubed root of x to the fourth would be the same as x to the 4/3 power. Right? The root would be the denominator of the exponent. And then since it's in the denominator, that means it would be a negative exponent. So I can rewrite this as x to the negative 4/3 power. So then take the derivative, bring this out front. So -8 times negative 4/3 would be positive 32/3 times x, and then subtract 1 from the exponent. So negative 4/3 minus 1 would be negative 7/3. Okay? Now, we can do the same thing to each individual piece of a polynomial. Okay? If I have multiple terms in a polynomial, I can just use the power rule on each individual piece. So here, for example, my derivative would just be, take the derivative of this piece, so 3x squared, take the derivative of this piece, that would be minus 10x, right? Bring the 2 down, subtract 1, plus 2, right? The derivative here, if we think about this, I can say the derivative would be, if I bring the exponent down, right, that would be an exponent of 1. So 1 times 2 is 2, and then subtract 1 from the exponent, so that would be x to the 0 power. But x to the 0 power is just 1. Okay, so the derivative of 2x would just be 2. Right? And we can also think about that as, well, this would be a linear function. Right? The slope of 2x would just be 2. And then we already talked about the derivative of a constant would be 0. So the derivative of x cubed minus 5x squared plus 2x minus 7 would be 3x squared minus 10x plus 2. Right? And we can do that here for any polynomial. Bring the 5 out front. So 5 times 2/5 would just be 2. Then subtract 1 from the exponent. Derivative here would be 4x cubed. Derivative here would be 6x. And then the derivative of a constant is 0. Okay? Let's do a couple more here. So on these, I want to rewrite the function before I take the derivative. Okay, so this would be x to the 1/3 power plus 5 times x to the 1/2 power. And now I can take the derivative using the power rule. Right? So bring the 1/3 out front, subtract 1 from the exponent. Bring the 1/2 out front. 5 times 1/2 would be 5/2, and then subtract 1 from the exponent. Same thing here. Now, my first two terms already have fractional exponents nicely written, but here I can rewrite that as 4 times x to the negative first. And now I can take the derivative. So this would be 15 halves x to the 1/2 minus 30 over 3 would just be 10x to the 2/3. Then bring that negative 1 out front, so minus 4x to the negative second. All right. Now, I'm going to have to turn this into 2 videos. So this is the end of the first video here.